Now we're going to learn about the dehydration reaction that happens in alcohols. A dehydration reaction is a reaction in which water is chemically removed from a compound. Specifically in alcohols, when you expose them with strong acid, specifically sulfuric acid, at 180 degrees Celsius, you will convert the alcohol to an alkene by removal of an OH group and a hydrogen. That's what converts into water. If we look specifically at an example, let's understand that in a dehydration of an alcohol, we are going to look more closely at the reaction that we see below. In the molecule 2-butanol, whenever we think about specifically dehydration reactions, let's understand that the alcohol molecule needs to be labeled. The carbon atom that is holding the OH, we labeled alpha. I'm going to symbolize alpha with a letter A. Then any carbon that it is tetrahedral and it is connected to the alpha carbon is going to be labeled beta. So in this molecule, we have a beta carbon on the left and a beta carbon on the right. I'm symbolizing beta with a letter B. As long as the beta carbons have a hydrogen atom in the beta carbon is tetrahedral, those are going to be molecules specifically that can undergo the process of dehydration to produce an alkene. So we can observe that specifically if this molecule, 2-butanol, the beta carbon in the left loses its hydrogen and the alpha carbon loses an OH, then we make water. Then, during a dehydration process, the beta carbon and the alpha carbon are double bonded. So we can see in the first molecule the creation of the double bond between the beta carbon that is highlighted in green and the alpha carbon, which is highlighted in yellow. Additionally, we can produce another alkene. That other alkene will be with the beta carbon that we have on the right side. We can observe that this beta carbon that is highlighted in purple, it is tetrahedral and it contains a hydrogen. So that beta carbon is going to lose the H. The alpha carbon is going to lose the OH. That's going to make another water molecule. And then we are going to double bond the alpha carbon and the beta carbon. And then we observe that this is the creation of the double bond. Remember that the removal of the atoms to form the water happens one at a time. So as long as the beta carbons are tetrahedral and contain hydrogen, we can make different alkenes. It is important to note that when it comes to alcohol being dehydrated and forming alkenes, when the alkene is surrounded by many carbon chains, and if we compare the products 2-butene and 1-butene, 2-butene, the carbon double bond is surrounded by one carbon chain, two carbon chains. That is going to be the major product of the reaction. When we look at 1-butene, even though it is formed, because this double bond is only connected to one carbon chain, that's going to be what we call the minor product. So in this reaction, the majority of the product will be the following alkene, but both will form. Let's actually look at the following example and predict what's going to be the product for the reaction. Menthol is a component in many ointments, including Vicks Vapor Rub. Now, if menthol is actually um, heated in the presence of sulfuric acid and at 180 degrees Celsius, let's predict the alkenes that will form in this reaction. I'm going to zoom in to look at the molecule more closely. First, I'm going to label my carbons as alpha and beta. In this molecule of menthol, carbon number one is going to be my alpha carbon. Because remember that alpha is actually written for the carbon that is holding the OH. Then, if carbon number one is alpha, that means that carbon number two and carbon number six are going to be beta. So this is a beta carbon and this is a beta carbon. Next, at the beta carbons, let me add the carbons and hydrogens if there's any. Carbon number two is a carbon that has a hydrogen. Carbon number six is a carbon that has two hydrogens. Since carbon number two and carbon number six are tetrahedral and they have a hydrogen, those carbons will dehydrate to make alkenes. So how do I draw the alkenes that come from this molecule? So overall, what we observe is that the molecule, I'm first going to redraw my menthol molecule. Let me just draw it straight into skeletal. I'm going to also highlight the different carbons. So I'm going to put the alpha carbon in yellow. And I'm going to put carbon number two in blue, which is right here. In order for the dehydration to proceed, what's going to occur is that the OH in carbon number one will go away and it will combine with the hydrogen in carbon number two. As a result, to form an alkene, I'm going to make a double bond between those two atoms. So that is the first product within this reaction. Let me now write what would be the product looking like if instead I take away one hydrogen in carbon 6 and the OH in carbon 1. So if I rewrite my molecule, and next I use purple to highlight carbon 6, which is right here. And I again highlight carbon 1 in yellow when specifically carbon number 6 loses one hydrogen and it combines with OH. That is going to produce water. And then the alkene that forms is between carbon number 1 and carbon number 6. I'm going to write the water molecule. So this produces two water molecules, one per alkene formed. Now, when I need to determine what is the major product and what is the minor product of the reaction, then I have to look closely at which alkene has the most carbon chains connected to it. When I look at the first alkene, I can observe that this carbon-carbon double bond is surrounded by one carbon chain, two carbon chains, three carbon chains. While the alkene on the right, these two carbons are surrounded by one carbon chain and another carbon chain. Since the molecule in the left has more carbon chains on the alkene, this is the major product of the reaction. And then the molecule on the right is the minor product of the reaction. Let's continue learning about reactions of alcohols. Now we are going to see another type of dehydration. But this dehydration, instead of forming an alkene, is going to form an ether. So if you have two alcohol molecules and you expose them to sulfuric acid, but now instead of doing 180 degrees Celsius, you do 140 degrees Celsius, what occurs is a dehydration, but it will result in an ether. Overall, what we observe in this system is that one alcohol will lose the OH, the other alcohol will lose an H, and then the oxygen that lost the H connects covalently to the carbon chain of the alcohol that lost its OH. So we can see that if we have two ethanol molecules and we expose it to sulfuric acid at 140 degrees Celsius, it makes an ether. Ethers are very interesting molecules. Mainly nowadays, we use them as solvents, but historically, ethers, specifically diethyl ether, was used as an anesthetic. Let's predict the product of the following reaction. Here we have 2-propanol as our alcohol. I'm going to rewrite our molecule in skeletal form. So 2-propanol has the following skeletal structure. And this value of 2 tells me that I'm going to combine 2 of them. So in this dehydration reaction, the first alcohol would lose the OH, while the second alcohol is going to lose just an H. So that means specifically that I'm going to make a water molecule that came from the OH and the H being lost in the two alcohols. Next, this section of the molecule, including the O, will be connected basically covalently to this part of the first molecule. So if I actually write these molecules where the OH are meeting each other, meaning I'm going to write it sideways. It is easier to illustrate what will be the drawing for the product of the reaction. These atoms still form the water, but when I draw the product, I write the first part of the alcohol, I connect it to the oxygen of the next, and then the rest of the molecule. Let me use my highlighter so you guys observe where I obtained that. The oxygen and the rest of the molecule is here. And we are going to connect it to the bond and the carbon atoms that are present. And that's how you draw the ether that it is obtained from the dehydration of this secondary alcohol. Remember that the dehydration is going to occur when we have sulfuric acid at 140 degrees. It happens to be that this secondary alcohol makes that product, but it can happen with any alcohol.